Algebra 2 Part 2. This is 822 Day 1. So we're solving quadratic equations by using the quadratic formula. So by the end of this you should be able to solve a quadratic equation with the quadratic formula. And then also we're going to talk about the discriminant and how that can help us to determine how many solutions a quadratic equation has. So before we can use the quadratic formula, there are two things that we have to do. So we have to get it set in a certain format. Okay, so first we're going to set the equation equal to 0, so we get everything on one side, 0 on the other side, and then we want to write with decreasing exponents. Right, so we want our exponents to be going downhill, squared exponent, x to the 1, and then our constant term. Okay, so remember a quadratic equation is, an example of a quadratic equation is ax squared plus bx plus c equals 0. And then the formula to solve that, I'll do this in a different color. So the formula to solve that is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Now, so far in this chapter, we've talked about several different ways to solve these quadratic equations. And so we talked about solving by, let's see, some of the methods that we've done to solve. I can put these up here. So the methods to solve, we've done factoring, we've done taking square roots, we've done completing the square, and now we're doing the quadratic formula. Okay, so these are the 4 different ways that you could solve a quadratic equation. You could factor, you could take square roots, you could complete the square, or you could use the quadratic formula. Now, the thing about factoring is it doesn't always work, only some of the times. And then taking square roots, that doesn't always work either. Your equation has to be set up in a certain way. Completing the square always works, but you learned in the last few sections that it's kind of tedious and it has a lot of steps. Quadratic formula always works, you just have to use a lot of arithmetic. Okay, so some of these methods are easier or more efficient than others depending on what you have going on. If you can see the factors really easily, if it's something that's really easy to factor, then factoring is easiest. If it's set up in a way that makes it really easy to take square roots and you don't have to do any other, moving things on one side of the equal sign or another, then that's probably a really good way to go. For completing the square, if your a term is not 1, and then you don't have to divide by it and worry about possibly getting a fraction, then it's easy to solve by completing the square. Quadratic formula works all the time, you just have to do some arithmetic, and we're going to go through that now and talk about that. Okay, so if everything is set up like this and your exponents are going downhill, 2, 1, and then your constant term, you can take these numbers. So what I'm talking about is whatever is in front of your x squared, whatever is in front of your x, and then your constant term, you take those numbers and then you plug them into this formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. You solve that and you get your 2 solutions. So we're going to go ahead and run through that classwork now. And we'll talk about the discriminant later. Okay. So if we go ahead and take a look at this classwork. Alright, so for number 1, we have w squared is 5w plus 50. So the first thing that we want to do is we want to set this up that we can use the quadratic formula with it. So we want to get it set equal to 0. So I'm going to minus 5w minus 50 minus 5w minus 50. So I have w squared minus 5w minus 50 is 0. Okay? And then, so my exponents are going downhill. It's set equal to 0. And then if I look at this, I can see a is 1, b is negative 5, and c is negative 50. Okay? And then remember the formula that we have, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to go ahead and plug these numbers into it. Okay, so first off, a negative b. Well, this b is negative, so double negative, so it's going to be a negative 5 plus or minus the square root b squared, so negative 5 squared minus 4 times a is 1, and c is negative 50 all over 2 times a, which is 1. Okay, so then we just go ahead and simplify this. So kick this down here. So double negative becomes a positive, so 5 plus or minus the square root of negative 5 squared is 25. Now I have a negative here, and I have another negative here, so that's going to turn into a positive, and then 4 times 50 is 200, and this is all over 2. So this is 5 plus or minus the square root of 225 all over 2. Now, 225, let's see, that's going to be the same thing as 225 is the same thing as 25 times 9. I think 225 is the square of 15. Let's see. If we do, let's check this. 15 times 15. Yep, 15 times 15 is 225. Okay, so the square root of 225 is 15. So actually, yeah, 5 plus or minus 15 all divided by 2. Now this is something that we're going to have to evaluate and get 2 answers for. So this is going to turn into 5 plus 15 over 2 and 5 minus 15 over 2. So this plus or minus, you're going to have to split things up and evaluate both. So 5 plus 15, we have a 20 over 2, so that gives us 10. And then 5 minus 15, that's a negative 10 over 2, which is a negative 5. So your 2 solutions are 10 and negative 5 for number 1. Alright, let's go on to number 2. So for number 2, t squared is 3t plus 40. So I'm going to subtract 3t, subtract 40. So then I have t squared minus 3t minus 40 is 0. Okay, so I've got everything set equal to 0. My exponents are going downhill, so I'm in good shape. So from this, I can see that my a term is 1, my b term is negative 3, and my c term is negative 40. Okay, and so remember what we're working with here. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. So we just plug those numbers into that. Okay, so negative b, so this is a negative 3 plus or minus the square root of b squared. so negative 3 squared, minus 4 times a is 1, c is negative 40, all over 2 times 1. So next step, this is going to be positive 3 plus or minus the square root of 9, and I have another double negative here, so that'll be positive, and then 4 times 40 is 160 all over 2. So this is 3 plus or minus the square root of 169 over 2. Okay, and the square root of 169 is 13. So we have 3 plus or minus 13 over 2. So we split this up. So I'm going to have 3 plus 13 over 2 and 3 minus 13 over 2. So 3 plus 13, 16 over 2, which is 8, and 3 minus 13 is negative 10 over 2, which is a negative 5. Okay, so our two solutions for number 2 are 8 and negative 5. So we're going to go ahead and skip around. The next problem is numbered as number 13. So for 13, we have 2x squared minus 11x plus 5 is 0. Okay, so this one's already set equal to 0, which is really nice. So we can identify our terms. A is 2, B is negative 11, and then C is 5. Okay, and then remember our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we take these numbers and we can start plugging them into this. So I'm going to have a negative 11 plus or minus the square root of b squared, so negative 11 squared minus 4 times 2 times 5 all over 2 times 2. So double negative here, so that'll be a positive 11 plus or minus the square root of 121 minus, well, 4 times 2 is 8 times 5 is 40, and this is all over 4. So this is going to turn into 11 plus or minus, and then 121 minus 40, that's going to be 81 all over 4. So kick this up here, so I'll have 11 plus or minus 9 over 4. So this is going to turn into 11 plus 9 over 4 and 11 minus 9 over 4. So 11 plus 9 is 20, so that's 5, and then 11 minus 9 is 2, so that's 1/2. So your answers for number 13 are 5 and 1/2. Alright, and then we'll check out number 14. So for 14, I have 6x squared minus 11x plus 9 is 0. Okay, so this one is already set equal to 0, and our exponents are going downhill. So a is 6, b is negative 11, and then c is 9. Okay, and then remember we have negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll go ahead and plug these numbers into this formula. So I'm going to have a negative 11 plus or minus the square root of negative 11 squared minus 4 times 6 times 9 all over 2 times 6. Alright, so we simplify this. We get a positive 11 plus or minus the square root. Well, this negative 11 squared, that's going to turn into a positive 121. And then I've got a minus. Let's see, 4 times 6 is 24 times 9. I don't know that off the top of my head. 24 times 9 is 216 all over 12. Okay, so 11 plus or minus So 121 minus 216 is going to give us negative 95 over 12. So let me just make sure that we set this up right. So let's see, A is 6, B is negative 11, C is 9. So then we've got negative 11 plus or minus B squared minus 4 times A times C. Yep, we did. Okay, so let's see, 4 times 6. Okay, so that's okay. This happens sometimes. And we can go ahead and simplify this to the best of our ability. So the first thing that we're going to do, if we have a negative under this square root, we'll pull that out as the I. Remember that from chapter 7. So we're going to have I root 95. Now we want to see if we can break 95 down at all. Half of 95 is 47.5. And so if we look at our list of perfect squares, well, 47.5 is about here. So if I go backwards, 36 is not a factor of 95, 25 is not, 16 is not, I don't think 9, no, 9's not, and 4's not. So 95 is as nice as it's going to get. And so that's all we can say for that. Okay, so it's 11 plus or minus I root 95 over 12. And so sometimes you'll have answers like that, and that's as far as you can simplify that. So let's go on to 19. 19 is going to give us an answer that won't be very nice, and that's why they have the directions to approximate it to the nearest thousandth. So we're going to end up plugging that into our calculator probably. So for 19, we have p squared minus 6p plus 2 is 0. Okay, so the good thing about this is it's already set equal to 0. Our exponents are going downhill. So if we identify our terms, a is 1, b is negative 6, and then c is 2. And remember our formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So I have, so for negative b, I'm going to have negative 6 plus or minus the square root of b squared. Let's see, so that'll be a negative 6 squared minus 4 times 1 times 2 all over 2 times 1. And so if we simplify this, well, let's see, double negative there, that becomes positive 6 plus or minus the square root of 36 minus 8 over 2. So this is 6 plus or minus square root, 36 minus 8 is, what is that, 28? Double check that. It's been a long day. Yes, 28. Okay, now, we know 28 is not a perfect square. We're going to end up with something left on the inside. So what we can do is we can just plug this into our calculator to simplify. And that's kind of what they're telling us to do anyways, approximate solutions to the nearest thousandth. So the only way we can do that is get it in our calculator. So what we could do is figure out the square root of 28. So, let's see, so 28, and then the square root of that. So the square root of 28 is 5.2915. So we're going to have 6 plus or minus 5.2, and if we want to approximate to the nearest thousandth, so that's 3 decimal places. So that's going to be 292 over 2. Okay? So if we split this up, I have 6 plus 5.292 over 2. And then I have 6 minus 5.292 over 2. So then I just do this in my calculator. So I'm going to do 6 plus 5.292 and then divide that by 2, and I'll get 5.646, and then I'll do 6 minus 5.292, and then I'll divide that by 2, and I'll get 0.354. Okay, so this is an example of something where the radical didn't work out perfectly, and so you can plug that into your calculator and get these decimal answers. And then later on in the second half of chapter 8, we would go ahead and plot these on the graph. These would be x-intercepts, and you can see they wouldn't be very fun to plot. Okay, so that's an example of number 19 where you have to get a decimal. Now 22, 23, and 24, those just ask you to use your discriminant to tell how many solutions you have. Okay, so this is on your handout, and so we want to go over a little background information on your discriminant. Now, your discriminant is just the piece of the formula that's underneath the radical. Your discriminant is just b squared minus 4ac. That's all it is. And what the discriminant does is it tells you how many types of solutions you have. So if b squared minus 4ac is, if it's 0, then you're going to have one real number solution. Okay, if b squared minus 4ac is positive, then you'll have two real number solutions. If b squared minus 4ac is negative, then you'll have two imaginary number solutions. Or I could say imaginary or complex. Your answers are going to include an I. Okay, so all we're doing for this is figuring out if b squared minus 4ac is 0, positive, or negative. So for example, for number 22, we have 9x squared plus 30x plus 25 is 0. Okay, so A is 9, B is 30, and C is 25. So b squared minus 4ac, so that's all I'm figuring out, b squared minus 4ac. So that's going to be 30 squared minus 4 times 9 times 25. So 30 squared is going to be 900 minus, and then 4 times 9 times 25, let's see, we get another 900. So then if we subtract that, we would get 0. So then that means we have one real number solution. And so your answer to 22 is just one real number solution. Okay, so let's do 23 and 24. So for 23, I have 2p squared plus 7p plus 3 is 0. So for this, A is 2, B is 7, and C is 3. So if I want to do b squared minus 4ac, that's going to be 7 squared minus 4 times 2 times 3, which is going to be 49 minus, and then let's see, 4 times 2 is 8 times 3 is 24. Well, I don't even have to go the whole way. I know 49 minus 24 is positive, so then my answer there is 2 real number solutions, and that's all I have to say. So going on to 24, for 24, we have 3z squared plus 1. So for 24, if you notice, your a term is 2, we don't have a b term, so b is going to be 0, and then c is 1. So then b squared minus 4ac is going to be, 0 squared minus 4 times 2 times 1. So that's going to be 0 minus 8. That's going to be negative. So then I'm going to have 2 complex number solutions. Okay? So for those problems, you just have to figure out positive, negative, or 0, and then tell what that means. And so that's it for 822 day 1, and hopefully you know enough to do the homework.